Jacobians. Let me define the Jacobians of two variables. Let u and v are functions of two variables x and y. Then the determinant then the determinant dou u by dou x, dou u by dou y, dou v by dou x, dou v by dou y is called the functional determinant or the Jacobian of u comma v with respect to x comma y, and it is denoted by j of u comma v by x comma y, or dou of u comma v divided by dou of x comma y. Similarly, if we have for three functions which depends on three variables, that is u, v, w are functions of x, y, z, then Jacobian of u comma v comma w with respect to x comma y comma z is defined as determinant. In the first row, it is dou u by dou x, dou u by dou y, dou u by dou z. Second row elements are dou v by dou x, dou v by dou y, dou v by dou z. Third row elements are dou w by dou x, dou w by dou y, dou w by dou z. Let me discuss the problem based on Jacobians. If u equal to x plus y plus z, v equal to x square plus y square plus z square, w equal to xy plus yz plus zx, find Jacobian of u comma v comma w with respect to x, y, z. We can observe in this problem, they are given to find out the Jacobian of three variables which depends upon the three independent variables, that is x, y, and z. We have the definition of Jacobians of three variables of u, v, w with respect to x, y, z is determinant dou u by dou x, dou u by dou y, dou u by dou z, dou v by dou x, dou v by dou y, dou v by dou z, dou w by dou x, dou w by dou y, dou w by dou z. Here, what are the things which we have to find out? All first order partial derivatives of the functions u, v and w with respect to x, y and z. So let me differentiate u with respect to x, with respect to y and with respect to z partially. So that is the first, let me differentiate the u with respect to x, partially treating y as a constant and also z also constant. So then what's the differentiation of x with respect to x is 1. Same thing, differentiate the u with respect to y, partially treating x and z as a constant. So the differentiation of y with respect to y is 1. The differentiation of u with respect to z, partially treating x and y as a constant, the differentiation of z with respect to z is 1. Same thing, we have to find out dou v by dou x. Dou v by dou x, which represents the first order partial derivative of v with respect to x. And we have to differentiate this with respect to x, partially treating y and z as a constant. So the differentiation of x square is 2x. And let me find out dou v by dou y. We are treating with respect to y, we are differentiating partially. So we have to treat x and z as a constant. It is 2y. And we had to find out dou v by dou z, means we have to treat x and z as a x and y as a constant. The differentiation of z square is 2. Now let me differentiate w with respect to x partially. We have to treat y and z as a constant. Then the value of the second term while differentiating with respect to x is 0. And the differentiation of the third term with respect to x, so that is plus z. Similarly, find out dou w by dou y. So the differentiation of xy with respect to y is x, and the differentiation of yz with respect to y is z, and the differentiation of zx with respect to y is 0. And let me find out dou w by dou z. Differentiation of xy with respect to z is 0. The differentiation of yz with respect to z is y. The differentiation of zx with respect to z is x. So substitute all the respective what we found the first order partial derivatives in the Jacobian's definition, and we were having that determinant dou u by dou x is 1, dou u by dou y is 1, dou u by dou z is 1, dou v by dou x is 2x, dou v by dou y is 2y, dou v by dou z is 2z. And dou w by dou x is y plus z, and dou w by dou y is x plus z, and dou w by dou z is y plus x. Normally we are doing the basic expansion of the determinant. So let me expand this determinant. So 1 into, you have to ignore the first row and the first column. We are getting 2 cross 2 determinant. Let me write the expansion of this 2y into y plus x minus 2z into x plus z minus 1. Now you have to delete the second column and the first row, we were getting the 2 cross 2 determinant and expand this. So 2x into y plus x minus 2z into y plus z. And now we have to delete the first row and the third column. We have the sign of the determinant is plus. We have 1 here. Expand this determinant. So 2x in. So x plus z minus 2y into y plus z. So simplify this. Uh, we were having 2y into y is 2y square plus 2xy minus 2xz minus 2z square minus same thing, you have to multiply this along with the sign. Okay. uh, it is minus 2xy minus 2x square, and then minus into minus is a plus. We were having 2yz plus 2z square and multiply this 2x inside. Similarly, minus 2y with the y plus z, and we were having that plus 2x square plus 2xz minus 2y square minus 2yz. So cancel of all the respective opposite signs. See the terms which is having opposite signs, 2y square and your minus 2y square and 2xy plus 2xy, your minus 2xy minus 2xz plus 2xz and minus 2z square, your plus 2z square minus 2x square and your plus 2x square minus 2yz plus 2yz. So the Jacobian of the given function is 0.